this is usually referred to as a graveyard shift, but it's not, as it doesn't look like a graveyard. It's quite buzzy. We're on an interesting topic. Let me introduce my panelists. To my left, I've got Simon Goldthorpe with Equinix. Welcome, Simon.
Thanks, George.
Mike Harrington, JLL.
Thanks, George.
And at the end, we've got Stuart Redshaw from EkkoSense. Hi,
Thanks,
Stuart.
George. Good to see you.
Yeah, it's good to see you too. What's funny, I always try to find a starting point for the panel. The panel's about AI. We had a prep call last week, and I used Otter AI, the application I used to transcribe calls, and it gave me a summary. And I sent the summary and the transcript to our conference producer that was on the line, who then put it into ChatGPT because she prefers that to do her conference notes. And I ended up something very different to what I remember the conversation being. But anyway, that's just a little bit on AI. We didn't start the conference on AI yesterday. It was more about regulation, but we're going to end on it. And we're not going to talk necessarily about the size of AI data centers, although we might touch on that, right?
We could do.
We could do. There was some interesting stuff in there, but we're going to talk about the conversation we've been having for the last 5 years. I think we can have this up here. We've been saying, oh, what's going to happen when AI hits the data center and how are we going to use it? Is it going to be fully automated? And we are in the age of AI now, and everybody's working out what they're doing at the moment with it. And I want to kind of like just start off easily on the working it out and where we are on the journey, and then we'll get into some more specifics. But can we kick off with, Equinix? Just where are you on this journey of AI being used in operations in the data center?
Yeah, it's an interesting question, George. And I think a lot of the focus so far has been on, how are we going to build data centers for AI? And I'm pleased that we're discussing, the use of AI in data centers, because, if you look around DCD, there are a few offerings in the world of AI and tools that are available. But my personal opinion is that we barely scratched the surface in the use of AI and what it can do for us in data center operations. And there's so much scope and so much that could be optimized by AI and uses of it. And yeah, as Equinix, we are using AI for specific tasks and specific purposes. And that's both, machine learning and also the generative AI. So, you can, for instance, a contract, you can go and query a contract now using a tool like ChatGPT to draw out, important operating clauses or SLAs out of a contract automatically. And then, there's obviously things like EkkoSense where we've got machine learning being used for optimizing cooling and solutions like that. And one of the big things as well, I think cybersecurity, a lot of companies either, maybe it's not at the front, but it's in the back office where, you're using sort of AI related cybersecurity tools to detect network infiltration and stuff like that. So I think my point is there's a lot of applications, and I think as an industry, we'd barely scratch the surface on what it can do for us and where we can potentially go with it in the future.
Okay, interesting. Well, you've touched on lots of the topics we're going to talk about and go deeper. And you stole a bit of thunder from Stuart explaining what he does. Mike, can you talk to us from a JLL perspective? Because you've got lots of customers, hundreds of customers, and you're JLL yourself. What's this journey of making head or tail of this opportunity?
Yeah, George, we're driven a lot by customers in the data center space. As a company, JLLT, big division within the organization, and we're obviously developing our own AI tools. But in the data center space, Simon touched on it perfectly, said we barely scratched the surface. I think it's that whole mindset needs to be changed as to allowing AI in to help with the operational efficiencies of a DC.
It's interesting. I'm going to touch. If Ian Bitterlin were here, he would be at the back, jumping up and down, going, "It's machine learning. It's machine learning. It's not AI." Can you touch a bit upon that? Because, for years you've been talking about machine learning. Then we've got AI coming up. Are there confusions around this, or is it, is it better to use one word or the other at the moment, or is it all just?
Yeah, there's definitely a a kind of a subtle difference between the two, but they do move from one into the other. And definitely at the machine learning stage, it's much more structured in the kind of operations that you intend the tool to do. So it's not deep learning where it can go in just about any direction and be more widely used. So certainly in our case, as we're seeing the nature of data centers has changed, particularly with the very, very high heat load densities we're finding with the AI style compute. You almost needed an AI machine learn style solution to managing that technology, because the heat fluxes are so intense. The rates of change are far higher than we've ever been used to in the industry over the last 40 years possibly, that it's almost needed the same technology that it's supporting to control it, which has been really interesting. That it's almost a self-fulfilling thing. You needed an advanced way of looking into the way that the systems are performing and the statistical inferences that you can get from machine learning in particular, but AI generally is really supporting operations of that equipment as it comes into service in the field.
You've kind of like jumped over here. You've gone into AI data centers, not AI being used on data centers. But it's an interesting point here. If we go to the topic of the title, resilience, there's a semantic issue here. Sometimes I feel that, machine learning seems quite process driven and controllable, and artificial intelligence seems that it's not in your control. And what you're saying there is actually talking about using AI in an AI data center is a completely different context, because they are doing things beyond what we've seen. Can you talk
Correct.
a bit more about this?
I guess it's how much insight do you want to get from the data sets that you're applying it to. So by definition, operating a data center is quite a structured application. So you really want to define the limits of what you want to do with it. So it really lends itself to that kind of thinking, particularly where you've got an almost a human machine learning interface there, because we need to be able to audit some of that functionality and some of that thinking. We don't want to allow it to go unstructured into areas that we don't really understand. So certainly in our space, which is in operational data centers and supporting that change, we want to be able to look over its shoulder and know the way that the machine learning has been structured, what it's intending to do, what information it's taking on board, how it's learning, and what the results are going to be from that. Because we're not looking at wider applications. We're not looking at using that data for a novel application outside of the space. We're not looking for the innovative breakthrough from that data set somewhere else, which is kind of the machine learn opportunity that may be possible. In the application, you want to keep it much more tightly reined in, keep it structured, keep it machine learned.
Interesting. I'm going to jump about a bit at the beginning, because you kind of like got to filter out what we're talking about. What is it's a wide area to cover. I'm interested in just going back a bit. Yes, yesterday I had a panel on the European Energy Directive. And I had some consultants here that are helping companies on their journey to understand the energy they're consuming. And I got a feeling that they were still going into companies that really are not that advanced in their telemetry within their building. Where I'm going with this is the journey to even start using machine learning and AI. Doesn't it need a lot of investment before you get there? Right,
I'm not sure I agree with that, George.
Okay.
But
I'm not the engineer. That's good.
But I mean, most of us operating data centers, we've got these huge BMS systems. We've got loads and loads of data. I think, and I'm not right out for comment, but certainly one of the biggest challenges, and speaking to other data center operators in the room today, is the data quality. So, the machine learning can only do as good as the data that you put into it. And a lot of times there's, the data quality, it's not consistent. It's not in a state where you can just feed it in and expect a sensible outcome. And I think, the first, major challenge that a lot of companies come against is we're all looking at what AI can do for us, but in order to get AI or machine learning tools working for us, we've got to have that data quality and standardized sort of data sets from all of your assets to be able to do something sensible with it. And I don't know, I guess, Stuart, if you You agree with that?
100%. Yeah, it's the quality of the data lake. So what you put in, you can then work on that. So if it's very high quality input data, you can do a lot of work because you can then really lean into that data set if it's of high quality. If there's some spurious data in there, then you need to be careful, or you're going to have a human involved in there to audit that and check it's good. But if you've got high quality data, then you can push the algorithms much harder. You can lean on them to give you much more challenging insights. But it does come back on, that's kind of a balance reward thing. So good data, a really clean data lake, and you could do a lot of good work with it.
Mike, Equinix has got Equinix's data centers. They've got a controlled environment here, right?
Yep.
You don't have
Very
such
much.
a controlled environment. Can you talk a bit about that data quality that you see out there?
Yeah, and I break it down into two areas really: the end user, server, rack, back to the infrastructure. And I completely agree on the infrastructure. We've got many data points. Are we using the right ones? I think that varies from data center to data center. But it's joining up that full journey is the key to getting the most out of AI, particularly in the sustainability and energy.
How big a problem is this data quality? Delving in, you come up with lots of different clients. What are the main offenders? Is there a systemic issue here that any machine before a certain date really wouldn't be able to provide the quality of data, or is it the interpretation, or what?
Yeah, I think it's hard to be specific, so it's horses for courses, but it matters where sensor data, where the sensor is, possibly slightly less on the accuracy of some sensors, because most temperature sensors, power meter stuff, that it's accurate enough to give us the insights we need, but it really matters where they're physically located. And that's what we find to be the greatest challenge. It would be dramatically bad for any kind of control algorithm, for instance, to think that one piece of data is coming from one location and actually it's something else somewhere else, because that could really make things fall over. So it's more about where that data is and mapping it onto that 3D model, onto your digital twins in our case, that really matters for us.
It's interesting because in the title again of resilience is an operational thing a lot of the time. If you can't trust the quality of the data, how long does it take to up the quality of data in order to get to a point where your clients are starting to see, sensible answers?
Yeah. I think it's always been the case. So when the industry was really reliant on BMS data, it really mattered, and that the industry has always been very much aware of that and invested heavily in the BMS to keep it operational. I think now, just with the power densities that we're at and the value of the compute that's going on in there, the value of the hardware, I think it's just ramped up a little bit. The cost of sensors has come down. The cost of digital twins has come down dramatically. That technology is widely available now through IoT, but it has gone up an order of magnitude in terms of granularity. The amount of data you need has increased, but its cost has largely reduced now from where it was, say, 10 years ago.
I'd like to comment on that.
Yeah, I mean, I think I was listening to a panel discussion earlier today about the design of AI data centers, how we're going to design data centers for AI. And for me, it feels a little bit like we're trying to put AI over the top of an existing design. And I think if you went back to the drawing board and you said, well, what inputs do we need to get a good output? What sensors do we need to monitor? What data do we need? And, from each asset, each piece of equipment you have, then you could get obviously a lot better outcome than just trying to layer AI or optimize something over existing data that hasn't really been thought or designed with that purpose in mind. So I think, in the future, I think, knowing that you're going to put an AI system or machine learning into operation and what the inputs it needs and what the outputs you expect from it, you could design a whole better system and put all the sensors and, data in place at the right quality on day one, rather than trying to shoehorn it in. We're kind of in the retrofit stage rather than, building it from the bottom up, if you know what I mean, today.
Yeah, it's interesting. Are you seeing it? You got retrofit, you build. Is it completely different the way that you analyze that technology requirement when you go into a client?
It's definitely legacy has its own particular challenges. So it's a different style of market. So you're retrofitting on machines that are potentially many years old and perform poorly. Potentially that leads you into doing a lot more investigation into specific machines. Perhaps more modern equipment, you could just interface directly and take direct information out of the machine. And on retrofit with older legacy equipment, you can't do that. And maybe you're finding a lot more faults and issues that are hidden in that. So it can be harder to do that retrofit solution rather than a new build deployment directly built for the AI systems.
Okay. Simon, you spoke before, when you gave your intro, that there were lots of interesting areas and we're only scratching the surface. It's energy management, predictive maintenance, adaptive cooling. I think we'll take cybersecurity on its own after, but in that operational sense, what are you closest to getting, good outcomes from at the moment?
Yeah, so I think, why I say we've just scratched the surface of it is there are a lot of, particularly around cooling optimization and that there's a lot of machine learning solutions available for that on the market and custom developed ones and so on and so forth. But really the point we're at the moment is we've always got a human in the mix. So you might set your AI in inverted commas to work on optimizing your cooling plant. But at the end of the day, it's going to spit out a set of recommendations and a human's going to look at that and then decide to implement that. And I think, there's a long way to go from where we are today with that to, handing over the complete operation of your cooling to machine learning, where effectively it just runs and optimizes everything and decides what it's going to turn on and off at will versus, using it to optimize and specifically spit out some set points. So at the moment, I think there's a bit of a gap between where we are today and where we could be in the future. And really, I think, going back to resilience, the reason we've got the human in the mix is because we don't really trust the AI to make those decisions, and we don't want to trust it to operate it. And actually, it's a risk rather than, reducing risk to fully, go and implement a machine learning tool that runs your whole data center.
Interesting. Mike.
Yeah, I think we all get the sustainability angle, but there are other efficiencies that will improve reliability. And when I look at the labor shortage in the whole data center industry, how can we make more of the predictive analytics, predictive maintenance patterns, looking at planning, all of those things? Even scenario training at the front end with the digital twins and other areas. For me, in an operations piece to improving their reliability and resilience, has got to be, how do we make the day of the technician more straightforward and almost working to a point where there is no opportunity for them to deviate too much outside the agreed parameters. Because it's when you get to deviation, you get issues.
Thank you. Stuart, can we kind of we're speaking about the risk that's involved and having a human in the way. And Stuart, you were talking about the application of AI in an AI environment that's running very hot, that's running very fast, where maybe the individual just hasn't got the time to understand it. Is that where you first think you'll start seeing more fully automated systems?
It's 50-50. So I'm a real fan of human factors. So I think that we need to invest in our humans. And to help them do their job and develop their skills is really important, and develop tools that make their work environment more interesting, more dynamic, because the fallback position in the event of an incident is that you're going to rely on the human to know what to do and to be able to exercise their skill and knowledge and experience to resolve an issue. When all's said and done, when the big incidents happen, it's the humans that resolve things. But at the same time, the dynamic nature of the AI heat loads are working too quickly and too suddenly, and the SLAs are so tight now that it's overloading for a human in terms of a workload to be able to deal with that on a moment by moment basis. So they need support and they need the tools to be able to do both. So there's an element of two things there. So we need to support the humans so they're ready in the event of there being an incident to interact with the machinery on site and know how to operate and how to do things to resolve situations, and have the creativity in their human thinking, which is so different to an AI approach, but have that human approach to resolving problems. But also on the day-to-day with these very, very high heat load densities that we need help. The humans need help of that type to get to the best and most efficient solution.
It's interesting that the conversation splits like so many do in this hall for the last 2 days, and actually for a while now. We've got this hyper conversation, and then we've got, I don't know, we call it real world. Traditional sounds too old for something that's still very cool, but there's real world conversation going on. And in this case, the hyper conversation, which has so much risk to it, requires that AI. And in the other world, probably the risk isn't great enough to need to invest in the AI.
I think, the opportunity is, talking about resilience is, and Stu sort of touched on it, is really about, predicting faults, predicting when the load's going to go up and down and being able to manage that better. And that's where you're really going to improve the resilience. If you can predict when your generator's going to fail or your UPS is going to have a problem and deal with it before it happens, then obviously there's a massive benefit in terms of data center resilience. So, we kind of talked about optimization and PUE and sustainability as being one application, but, fault prediction, predictive maintenance, and, it's going to be an area where potentially you can make great steps in improving data center resilience.
Is there budgets in your world for this? Clearly, we know that in the corporate world, every board is talking about AI and what's our AI strategy, and that filters down to someone in the capacity department who then has to say, well, we can get funding for so many projects. And is this happening here in the operational world? Is it business as usual? Is there budgets, money to play with in inverted commas?
Yeah. And I think it's a good point. And certainly like AI tools, sustainability, they've got to have a return on investment. And, some people can be in danger of spending a lot of money on something that actually doesn't yield a return on investment. So, if you're going to invest in an AI tool, it has to show a return on investment. And that's why sort of energy saving and building optimization solutions are so popular, because they've got like a clear return on investment. You spend that on the tool, you're going to save that much in energy. And then everyone's like, yep, we'll do that. I think it becomes a bit more nuanced when you're talking about things that are improving service, because, the values are a lot less tangible. So yeah, we've got this AI tool that can reduce outages. Okay, well, what's the value of that? How many outages does it present? It's a lot less, tangible, I think. So that's why I think there's been a lot of focus on optimization solutions. But, I think when the confidence of the market increases in other solutions, such as, preventive maintenance, fault detection, load management, that side of things, and everyone can see the value in them, then there'll be a bigger uptake in the industry in those things.
Absolutely, 100%. I wish we could find a way to prove the benefit of the outage we avoided, but you can't. So yeah, absolutely, 100%.
For me, I think it's when we make the shift to letting AI control equipment. At this point, we're using it for data gathering, collection, make some informed decisions off the back of that. But when do we make the step change and let AI drive some of the infrastructure? That's when we will probably see some of the real benefits. But it's going to be a brave operator or user that makes the first step.
A brave operator. Who's going to be that brave operator? Is it going to be what you said before in the hyper world?
I think there'll be. So there are already niche applications around that solve little pieces of it, and eventually there'll be so many they'll start to coalesce together. So bits and pieces, certain business propositions, applications will work, and there'll be demand in the market. They'll deliver a benefit that can be justified and proven. others won't and fall by the wayside, and eventually some kind of stability will occur in the market, and we'll see that coalesce together as the operational AI solution, and there'll be a number of vendors with particular competencies in that space. So it's early doors with that. So really interesting time.
Yeah, and I guess it's having fungible infrastructure and having Nokia's AI talking with the facility AI, looking at what network traffic problems there are and risking it each second. I guess we're a way off that. But we're at the start. Can we do a little straw poll with the audience here? Just to wake everyone up a bit. An open question. Who is using AI at work in any way in their day-to-day functions?
We have to put our hands up as well.
Yeah, why not? Just do it. I am. Been through 2 AIs, this piece of paper. I shan't do that again. Okay, then anybody using AI in any operational sense here within a data center? Okay. Might be the only 4 people close enough operationally to the data center. Okay, so that's kind of like that's.
Yeah, it's coming.
Yeah.
It's coming.
You get that feeling, don't you? Let's talk about cybersecurity. It's not a topic I know really anything about, although I know it's very bad, and I know people can use AI for all sorts of things today, right? They can find out about equipment in data centers. They can understand things. How do you take that at Equinix? So many facilities.
Yeah, I think Equinix has had been using AI in the security center for a number of years, and I think it's one of the earliest applications was analyzing network traffic to detect things that were out of the ordinary and to pick them out, because you can imagine in a huge organization with the amount of network traffic we have, there's tons and tons of data. A human cannot possibly sit in front and pick out, well, okay, that's suspicious, that's a threat, someone's opened a port there that they shouldn't have done, that they wouldn't normally. And I think the cybersecurity's the application that's quite well proven, and it's out there and we're using it now. Are we using it to its full extent? Is there more scope for it in the future? I'm sure there is, but certainly there are applications, and AI is well proven in the cybersecurity sector for threat detection and threat prevention and network traffic. So it's an interesting element, and obviously it feeds very well into data center resilience, because it's not just about the hardware and the plant. It's about the networks as well in the data center, keeping them up and running and safe.
Mike, how's that with you? Because within the organizations you work with, you're not necessarily always close to the IT, right?
No, we're not really responsible for their cybersecurity. However, from an operations perspective, all the networks are closed. So the challenge is when the OEMs come in, want to firmware upgrade, how do we protect the internal systems versus? So it's a challenge that I think is going to take some time to get over yet.
Yeah. And you said just a moment ago, Simon, that it was a common trait with what Stuart had said. When there's too much data and you believe there's gold in that data, there isn't a human that can look through it. So that becomes...
Yeah. So for us, we're very careful not to ingest too much data, because we don't want to learn too much. We need to know enough to add value and deliver on our business cases and make sure we do a good job for our clients, but we don't want to learn too much. So
explain that a bit more. What's too much? Because I always thought in the idea, more data, better.
The classic use case in our industry would be if, for example, we were able to integrate with the IT equipment directly. It would be really helpful, because we could see temperatures and power consumptions almost at chip level throughout the IT stack. But the question is, where does that stop? So there's 2 elements to that. There's could you have taken more data out of that, other parameters from the IT equipment, and also being that close to the actual machinery, are you learning about its behavior, and could that be reconstructed elsewhere and used for ill-gotten gains? Could you have learned something about the operation that you shouldn't know? So there's definitely a balance about getting the right quantity of data, of good quality, but you don't want to go mining things that you don't need in our industry. So there's definitely a line that we don't want to cross.
What are we learning from the other side? Because you said if I could go, into the computer, and for years we've been talking about chip level monitoring, and I remember, 12 years ago, Intel came out with the idea that we could just see maps of all of the chips, and we know exactly what's going on in there. Is there a case there comes a point where IT sees more than facilities because facilities hasn't implemented this quick enough?
You could imagine a place in this future, and that was probably the promise at that time 10 years ago, where there only needs to be one data set and it's everything for everybody, and we all tap in, and there's a happy world there where we can all dip into this wonderful data lake of everything. But I think we all know from the industry that there is a demarcation line between what goes on inside the rack, the customer base that are operating their IT equipment, and what facilities are doing on their side. And I've yet to see any facilities. It may be slightly different in hyperscale, but I rarely see any facilities that cross that line.
Mike, a while back, I remember seeing a 3D visual. It was like a digital twin that you guys have been playing with.
Yeah, our virtual reality models allow us to, mimic certain systems, have engineers work on those systems virtually, and the technology's gotten so much better. They're very realistic.
Yeah, that's taking us down this route of education. Yesterday, Rod Evans was the guy from NVIDIA that lots of people are interested in listening to, that said that NVIDIA wasn't causing any power issues. They keep on using that line. He gave an example at the end of a gas engineer coming to fit your house, and every house has a different boiler, and the engineer doesn't have all of the handbooks. Would it be great for them to access it? Data centers are clearly environments like that, with multiple versions of different types of equipment. Is that something that's starting to be used? I mean, you must have thousands of SKUs of different batteries and
but I'd hate to count the number of different manuals that a tech would need. So it has to be that way. But what we're also doing is, using camera tools. You can bring in an expert remotely and work through your, FaceTime for a conversation. So you're not necessarily relying on the individual getting to site within the phone, but you're able to actually do that much quicker, cut out the travel time, draw on their expertise to guide the on-site technician through what needs to be done.
I've heard on that vein, people banning the use of Chat GPT and things in the work environment as well, because if you don't know the answer and you're fed it, you won't be able to inquire. Equinix, you've got hundreds, thousands of people working in the data centers. Are you leveraging this, what we'd call generative AI at all?
Yeah, definitely. I mean, we've got our own version of ChatGPT at Equinix that we run. You can ask it anything and so on and so forth. But certainly there's tools available that will take a document or a suite of documents. So in theory, you could feed all of your operational manuals in there and then ask it a question to say, how do I change the battery on that UPS? And it would, spit out the text out of it. But that's a very sort of crude application and probably not the best use of AI compute time, to be honest, because you could also look at the index and find the page yourself. But I think going back to sort of Stu's point, when you've got a large data set, the value of AI becomes more worthwhile. So almost like, if you had to look through a 500-page, contract and you're looking for a specific line, feeding that into an generative AI tool and being able to ask it, what's the line, on SLAs, or what's the line on, termination agreement on a contract, it can pull that out without you having to search through it. But I think we've got to be a little bit careful on, overusing AI. And I think, some people think it can solve everything and are trying to use it for all sorts of different applications. And actually it's not it's not really saving time. It's not actually faster to type a query into ChatGPT and read the response as it is to, type it in the search box in Adobe, and find the page yourself, So I think we've got to be a bit careful. There's a balance to be made between, overusing AI and actually, using it for a purpose that actually saves time or optimizes something.
Coming back to your point, Stuart, of too much data, you're applying machine learning to particular problems in particular rooms and understanding them. And like you said, too much data can sometimes not be helpful. Is there a case yet of putting all of that data together and allowing machines to run on it? And doesn't it work like that?
Could do. It definitely could do. We're not at that stage yet, so we're being very careful to silo the information that we have and not to draw too wider inferences from it, because that is when you get into the generative AI kind of application. So we've a bit of innovation interest in those kinds of applications, but at the moment, much more structured when we're working in operational data centers to solve that application. We're not looking for wider use cases outside of that yet, so it's not for us at the moment to go into those things.
Okay, it's a kind of like a roundup. We're at this point in time where we're having a much more real conversation, maybe in years before. Generative AI has made that change now. It's common parlance. We're talking about real use cases, whether it's looking up a manual or whether, it's operating different pieces of plant. We know that there's a speed to this everywhere now, as in things are happening very, very quickly. Can you kind of just give your own perspective on where you think you will be in a year, to give the audience just an idea of what your velocity is in this? And remember, every person here's velocity is different because of their fundamentals. I'm saying that because Mike's got hundreds of data centers to look after, and he's looking at in aggregate. You've got a controlled set, and you've got many clients. So what's that year ahead? What can we expect?
I'll get my crystal ball out.
That's
George,
exactly what we're looking for.
I'm not going to make any sweeping statements of where I think Equinix is going to be.
It's just to help.
I think if I look at where we were last year and the conversations that were happening last year, is there was machine learning tools out there. I think we've seen massive step change in generative AI and what it can do, and I think, the big steps over the next 12 months, I think, are going to be in that generative AI space. So, getting that more human-like response to things. And we're going to see a lot more applications of human-like responses, AI-generated solutions that are really trying to sort of not replace a human operator, but assist a human operator. So to make life easier. So I think getting the crystal ball out again, the sort of in a year's time, we'll be seeing a lot more of the Gen AI stuff. And I think the machine learning piece is also going to progress. And we're going to see much more machine learning optimization solutions coming onto market. And like Stu said, hopefully, who knows, in a few years' time, we might have, hive mind or something. I don't know what the term is, running all our data centers globally. Who knows what the future holds?
Equinix OP1 Android.
Yeah, maybe we should ask ChatGPT for its predictions.
Yeah.
Might just tell you what we want to hear. It's very difficult for us because we work with so many different end users, operators, etc. I think sustainability applications are the focus for the next 12 months, particularly with legislation changing, being enforced. On our own side, I think it will be people driven. We will look at training program scenarios, how we can give the technicians the skills to do the job and make it easier in the field.
Yeah, I think that's a really big, I think that's a big move. There's so much disparate information. It's a way of really making things concise and easily to consume. From a technology developer and innovator perspective, what's your
we'll
answer?
continue to use it. So it's been breakthrough technology for us over the last few years to be using it to build the statistical inferences that we need to do the work that we do. And I guess the thing that we have this operation in so many data centers. We see such a vast array of data centers now. The hardware is landing now, so it's coming. So we can see it. The applications are running. We're starting to learn how it's being loaded up. We're seeing how different it is, how unusual it is in the traditional data center footprint. It behaves very, very different. Obviously, very, very high heat loads, but the rate of change is just a very different beast to operate in a data center. So we will definitely get a lot closer to that, and I'm sure that'll drive a bit of innovation from us to meet that business requirement, to get the best optimization solution, to de-risk that, to help with design potentially. So there's a lot of work coming from us to keep pace with that change.
Could you describe, just thinking with the audience, that heat map that you were seeing when there was an incredibly dense deployment that you were looking at, and you were kind of like through your software watching the changes?
Yeah, it's just for many, many years working in data centers, and we never got blasé or casual about it, but there was a certain cadence to the rate of change of a traditional data center that you could become accustomed to as an operator and be used to the way it would work at a weekend, or do you know what I mean? There was a certain cadence to the industry that's gone now. So yeah, the anecdote I was telling George about would be at a certain time of day and a certain customer, you'd be working in a data center and you'd think your eyes were getting a little bit sleepy, and you'd realize that the entire AI computer just kicked in and its heat haze across the top of all the racks has suddenly landed as a couple of extra megawatt had hit the room. So it's very dynamic, very exciting, but kind of a different world, really. So much tighter machines capabilities needed to manage them.
Really interesting. There's so many different futures right now, aren't there? I guess a lot of responsibility is required in the decision making around this. Thank you very much. I wish you the best of luck this year with all of your personal AIs and AI assistants and AI in the data center. I hope you got some value from this. And we'll always be interested in hearing your stories about usage or any major failures that have come about because of AI. Please write to editorial@datacenterdynamics.com. AI problem. Said Moss will be happy to write that up. No. Thanks. I don't know. Is this the last panel? Okay, this is the last panel, but as you can see, it's still not a graveyard. There is beer. There are people to talk to. There are vendors to speak to. There are friends to speak to. So please carry on enjoying yourself. Thank you for being such a great audience, and thank you for staying through the 2 days. We've had a fab time in our new venue. I believe having a bit of light adds to the photosynthesis of conversation here, certainly giving energy to all of us. So thank you very much, and thank you, panelists.
Thanks, George.
Thanks, everyone. Cheers.